A very good day to the panels. I'm Tan Kirin with metric number AN190197, and my supervisor is Associate Professor T.S. Dr. Noor Haslina binti Hashim. This is an overview of my final year project poster. So let me kickstart my presentation. Okay. The title for my final year project is Investigation of Metal Salts and Surfactant Interaction for Anionic Surfactant Detection with Different Types of Surfactant. The reason why I conduct this study is because surfactants are frequently used in pesticides, detergents, petroleum, and cosmetic. The water quality is still being questioned due to traceable pollution primarily and especially from anionic surfactants. This study involves a laboratory investigation that includes determination of metal salts that was proposed based on their capability to interact with anionic surfactant, and the metal salts chosen to construct a calibration graph to observe the interaction of metal salts with different types of surfactant, which are Twin 20 and Triton X100. They are both non-ionic surfactant, and DDAB, which is a cationic surfactant. As a result, in this study, copper 2 bromide shown a good interaction against anionic surfactant SDS. The calibration graph of absorbance against concentration of anionic surfactant for copper 2 bromide with R-square value 0.9941, which is almost equal to 1, indicates that the value of absorbance is completely explained by the concentration of anionic surfactant. Different types of surfactant were tested and absorbance was obtained. By utilizing the calibration graph, all of the final concentration has been calculated for all types of surfactant including SDS. It had concluded that copper 2 bromide metal is only had a good response with anionic surfactant SDS and shows negative responses to non-ionic surfactant and cationic surfactant. Surfactants are chemicals that lower the surface tension between two liquids or between a liquid and a solid. The discharge of these compounds to the environment can cause foam formation, groundwater pollution, and create an ecological hazard to aqueous organisms. Meanwhile, anionic surfactant also can cause human health problems, including dermatitis. There are actually many detection and qualification methods to detect anionic surfactant, but the use of methylene blue active substance (MBAS) is one of the most common methods for anionic surfactant analysis using metals. However, this method is quite laborious, as repeated extraction with toxic chloroform has to be carried out, which is also very time consuming. So, in this study is to carry out to investigate the possibility of using the interaction between the proposed metal salts and surfactant without using liquid-liquid extraction, as well as to investigate the selectivity of surfactant by constructing a calibration graph. There are 4 types of surfactants which are non-ionic, that it has no charge on its hydrophilic head, anionic with a negative charge, cationic with a positive charge, and lastly amphoteric surfactant with both negative and positive charge on its hydrophilic head. In this study, it was mainly focused on anionic surfactant. This is because anionic surfactant is the most common pollutant in water sample. The anionic surfactant chosen in this study is SDS. This is because based on the research that I have studied, the previous researchers anionic surfactant detection mostly relied on SDS analysis. Spectrophotometric method is used in this study, which consists of ion pairs formed between copper 2 bromide and SDS. This is because SDS carry a negative charge and copper 2 bromide carry a positive 2 charge. They are held together by an electrostatic attractive force. In this study, it also says that copper 2 bromide behaves similarly to surfactant SDS because of their mononuclear nature and share structural characteristics. However, TEA, that is triethylamine, is still needed to use in this study as a stabilizer to stabilize the solution of copper 2 bromide and SDS. Here's a picture shown of a basic instrumentation of a spectrophotometer. The solution was mixed together in a glass cuvette, and was fixed of a wavelength range 400 nanometers to 800 nanometers, which is visible where absorbance can be measured. After that, a calibration graph can be constructed to predict the concentration of known adsorbents. All the sample solutions were freshly prepared. Next is the methodology part. Firstly, I will prepare all the chemical solutions, standard solutions, and reagents shown in the picture here. For example, the preparation of metal salts, SDS, TEA, and different types of surfactant with concentration 0.05, 0.15, and 0.4 millimolar. This is the sample solution, and they will mix together in a glass cuvette before inserting to the UV spectrophotometer. The capability of metal salts can be determined by observe the interaction of metal salts with anionic surfactant after the measurement of absorbance. The metal salts will be discarded if it does not interact with anionic surfactant. If yes, it interacts with the anionic surfactant, the determination of absorbance the measurements for the absorbance value will be carried out again for the metal salts chosen and to construct the calibration graph of absorbance vs concentration. In the meantime, determination of different types of surfactant in different concentration will be carried out. This is the example of the different types of surfactant, which is twin 20 and triton X100. They are both non-ionic surfactant, and DDAB is a cationic surfactant. For the results and discussion part, copper 2 bromide was chosen because it shows the most stable graph with minimal fluctuation and overlapping compared to other metal salts. It also shows smooth curve and trend where it follows the sequence according to the concentration. Next is the determination of anionic surfactant. As we can see that there is a slightly gentle increase starting at a point 650 nanometers wavelength. Therefore, after the determination of anionic surfactant, calibration graph of absorbance versus concentration can be constructed. Here's a linear graph shows with equation y equals to 0.012x plus 0.05. This equation is used to calculate the final concentration of different types of surfactant. In order to calculate the final concentration for different types of surfactant, absorbance value must be measured first. Next is the determination of different types of surfactant. After the measurements of absorbance, the graph absorbance versus wavelength for each types of surfactant, SDS, twin 20, triton X100 DDAB was constructed. For example, the graph shown here for the SDS for the anionic surfactant, that we can observe the absorbance value shown here, and it was tabulated in the table shown here. After that, I can use the equation from the calibration graph to calculate the final concentration here. As we can see, the final concentration for anionic surfactant SDS shows positive value, while the final concentration for non-ionic and cationic surfactant shows negative value. This result obtained shows good indicator. If the reading shown is negative, then it indicates that the SDS does not exist in the water sample. If the reading shown is positive, then it implies that the SDS does exist in the water sample. In conclusion, this study revealed that the copper 2 bromide has a good interaction with anionic surfactant SDS, and a 99% calibration graph was constructed. It implies that this study is specific and selective only to anionic surfactant detection. This selectivity of surfactant types experiment indicates that the copper 2 bromide has the potential to be one of the possible metal ions used specifically for anionic surfactant detection and qualification only. To confirm the validity of the selectivity of anionic surfactant by metal salts, a thorough and in-depth research of the metal salt surfactant response to other surfactants is necessary, as this study is only the preliminary stage of anionic surfactant detection. That's all from me. Thank you, and I'm looking forward to meet the panels in the next Q&A session.